Ever tried to animate something you built in geometry nodes in Blender and you hit a wall? You build a beautiful parametric model, and the moment you try to rig it, it feels clunky and disconnected. I ran into that exact problem, and my software engineering brain just wouldn't let it go. Hey everyone, welcome to Dad's Projects. I'm a dad with a software development background. I apply that engineering mindset to all sorts of DIY projects, from home automation to, well, this. In this video, I'm not just showing you how to build a parametric folding door. I'm sharing a workflow that cleanly separates your geometry node models from your animation rigs. It's a system that makes complex animations much more elegant and scalable. I'm brand new to Blender, so I'm here to learn as much as I share. If you've ever been frustrated by this, stick around and let's jump in. For a 3D geometry node model, we need to add an object to attach the geometry node modifier to. So I'll just quickly do that. We'll just add a cube. Now we add the modifier. We can do it in the geometry node viewer. Just hit new, or we can go into the panel on the side and add the modifier. Now I have a parameterized model geometry node group of a panel of the folding door. So I'll just bring that quickly, and now it has some initial sizes, a parameterized model. It's already set to 500 mils width. We can set that to 2.1 meters high, and that's our panel. The panel is made up of a number of parts. If we go into the subnode group, we can see we have a couple of subnodes, group nodes. The first one is the main frame, so I'll just mute these so we can see that. The main frame is just an aluminium tube, a square tube, 50 by 50 mils. If we have a look at this subnode group, it's mainly just math nodes. It takes care of scaling the top and bottoms in the X direction and the two side in the Z direction. So if we simply go back here and we change our size, we'll see that this is scaling appropriately. I made it 750, and we'll just undo that. Let's just go back in. The next one is the sun glaze extrusion. This is what holds the polycarbonate glazing. So if I enable that, this node takes care of the two side extrusions. As you can see, we have a look inside there. Again, it's mainly math nodes, nothing too complicated. I'm not going into detail on the 3D model because it's not the focus of this video. So if we go back, this one is the actual glazing, the polycarbonate. So if we enable that, we can see that. And this one takes care of scaling in the X and Y directions at the same time. And it basically looks like that. The last one is just the F aluminium extrusion profile on the top and bottom. So if we enable that, we see that coming in. So basically that's the panel. And if I go in here, I can very easily change the size. Let's say I want to make it, well, it's gone to 600, or I want to make it 750. All I have to do is just change the width and it'll change. For the folding door, we need more than one panel. We need a point for each geometry node generated panel. With Blender's armature rigging system, only objects in the 3D viewport can be parented to bones. So we'll just make our points out of empty objects, which I'll just do quickly. Use plain access, just duplicate it, and we know it needs to be a width of 500, so So we'll set that at 500. Now I'm just going to add some collections into the outliner. It'll become clearer as we progress why we need the collections. So we're going to call this our folding door, and in here we'll create another collection. Actually, just have to do that. And we're going to call our points motion trackers. Again, I'll explain as we progress why it's called motion trackers. And we'll add these points to the motion tracker collection. We'll call the first one panel A, and we'll call the second one panel B, and we'll move our cube that we added the modifier to, and we'll just call it actual, because it's the actual door. The motion trackers serve two purposes. One is the point, the origin point, from where the model is generated by the geometry node. The other is to translate the motion, the transform that originates in the rigging to the model. In the modifier, we get the motion, the transform, rotation, scaling, and movement of the motion tracker using an object info node that is associated with it, the motion tracker. Now to create our points, all we have to do is just drag in this collection, and that gives us a collection info node. We can get it from the menu as well. This is already associated to the motion trackers collection. We need to make sure that this is separate, and it's best to be relative. And we need to feed this simply into an instances 2 points. Now normally what you would do is you would take this and pass it into an instance on points, so that you can plug in your instance. In this case it's our panel, and if we feed that into there, we'll see that we have our 2 panels, each panel on each motion tracker, which is acting as a point of origin. Now we have to get the information from the motion tracker, its transform information, and translate that to the model. Now I have a node that already does this for us. It basically contains the instance points and the object info node. So we just take this away for now, and we'll bring it in. I've just called it linkage for now because it ties the motion tracker to its index. So we feed that into that. Goes to our geometry, and instances is fed into that. Now it takes a few parameters. It takes a motion tracker. We specify the motion tracker and the index. At the moment now it's index 0, which is pointing at the first motion tracker. We switch this to 1. We see that's the second one. So to have both panels at the same time, all we have to do is duplicate this, feed this into here, and this time we need to change this to the second panel, and this should be 0, and this one should be 1. Feed that into a joint geometry, put that into there, just bring this in here, and we have our 2 panels. Now we'll just go into the linkage node quickly and see what's in it. Basically all it is taking our inputs, feeding it to the instant on points, and it uses the index node, and depending on what index we passed in, it will select that motion tracker, and we grab the rotation. We only need the rotation information, so we only feed the rotation information into the instance on points. So basically that's all the linkage node is. Now as we can see, when we rotate the model, it is not rotating on the corners. Now for the folding door, we need to rotate on the corners. So this is where you're going to run into a major problem. You cannot move the pivot point of a geometry node generated model. However, there are workarounds, and I'll quickly show the workaround. We're not actually going to use that, and I'll explain why a bit later. We can simply replace this. So what we can do is we can move the model so that the pivot point is where we need to pivot on, do the rotation, and then move the model back. So basically you can do that with 2 transform geometry nodes. So I already have a node group here which actually does that. It's exactly the same as the other, the linkage node group, but adds these two transform geometry nodes. So if we go back here, we just have to bring this in and take this here and just take this one out. So basically this is going to be, let's just make it our first panel, click 0. Now to move the pivot point on the first one, I'll move the model. So to get this to, let's say, this corner, so what we need to try and do is get the pivot point on this corner for the first panel, then it will be the opposite corner for the next panel, and so on. So going back to this, what we can do is we can, in the first one, we can move the model. We can take it like, needs to go 25 to get to the side, and it needs to go in the Y by 65 mils, and that brings it now to the corner. And basically in this one, we would have to do the rotation and then bring it back. So this would have to go minus 25, and this would have to be in the negative 165. So basically now we'll see that when we go and rotate this, it is rotating on the corner. However, doing this would add complexity and violate a fundamental software engineering principle, separation of concern. We have two parts, the 3D model and the rigging, which need to work together. Neither part should be aware of each other's implementation details. In this case, having the model implemented in a specific way for the rigging to be able to perform its responsibility. This creates dependencies where either part cannot evolve, grow, be modified, replaced without impacting the other. So instead, we're going to do something quite different, which provides loose coupling, no dependencies, and avoids unnecessary complexity. We'll be using Blender's parent-child compositional capability, where the child inherits its transform from the parent. So we'll be moving on to the rigging part now. Okay, for the rigging part, let's just get rid of those, bring this back in. We're just going to hide the 3D model for now. Okay, what we need to do is we need to create some mock doors to be able to couple the rigging to the 3D model. So I'm going to create 2 cubes. We need to give it the size of our door. Next direction is 500. Y direction it's 88 millimeters, but I'm going to make it 90. So it has 2 millimeter gaps on each panel, which makes a 4 millimeter gap between the panels, and the height will make it 2100. Okay, that gives us our first panel. We create a second one just by duplicating that X direction by 500, and that gives us 2 cubes. Now what we'll do is we'll add another collection here. We'll just call it mock, and we'll move these into the mock collection. And those are the mock doors. Now we need to create the armature system. Cursor to the corner, Shift S, selected, and I'm just going to set its origin to 3D cursor. I should do this for the other cube as well, so we get our corners, our origin points on the corners. Do this, I'll just move the cursor, I'll move it to the top corner, so this corner over here. So first we've got to go in the X by 500, and then we have to go up by 90, and then we go set origin to 3D cursor, and we'll set that one. I'm just gonna add the armature to the cursor. So Shift A, armature. As you can see, we need to rotate it. So let's just rotate it and X over the Y. And we have to rotate it by 90. And as you can see, it's way too big. So what I'm going to do is I'm just going to move the cursor to the other side. Plus 500. I'm going to edit mode. That. And that's already selected, so we're just going to go Shift S, selection to cursor, and that'll reduce it. Now we still need to be in edit mode because we need to add its parent. So just duplicate that. I just put it for here now, and just move the cursor to the other side. Next, I want to go -1000 this time, and Y I want to go -90, and then we just go Shift S, selection to cursor. Now this spine is with a child of this spine, so select the child, then we select the parent and Control P, keep offset. So now I'm going to pose mode there. You see that's rolling together, but when we rotate, we want this child to rotate in the opposite direction. So what we can do is we can simply go and add a constraint, add a copy rotation. And if we go and have an enable the axis, we can see that the X direction is the global Z direction. And we need to copy the parent, this one. And as we saw, it needs to be over the X direction. Now this needs to be local space. That'll fix that. So now when I rotate this, it rotates it. However, it's not fully rotating. The reason for that is that it's inheriting the copy rotation from its parent. It's inheriting the rotation from its parent, as well as the rotation from the copy rotation. And that's cancelling out the rotation, so it remains straight. So to fix that, all we have to do is go into the child's properties, and in its bone properties, and in its relations, we don't want it, at the moment it's inheriting from bone 001, which is this one over here. We don't want to inherit the rotation. So now, disable that, unselect it. It should be doing what we want. But as we can see, we can go too far. And we can limit that simply by going to the parent and adding a bone constraint on the parent and limit the rotation. Limited in the X direction. Again, this needs to be a local space from 0 to 90. So now when I rotate it, it should be doing what we want, and it's not going further, which is correct. Now one more thing we need to do to the armature system before we couple it with a 3D model is we need to, when we add more panels, we need a point to extend it on. So we need to add a point at this corner over here to be able to extend it with more panels. So what I'm going to do is go to object mode. We need to move our cursor to the other side, to that corner. So it needs to just go 1000. Okay, and all I'm going to do here is just add an empty object, another plane axis, and we'll just call this object extension point. Now what we want is when we rotate this armature, we want that extension point to move with this bone, which it's not going to do yet. As we can see, we'll rotate this, it's not moving it. What we have to do is take this armature, we've got to select it over here, and parent it to this bone. So shift, select the bone, and then Control P, and we want bone relative. So now when we rotate this, it's pulling it with it, which is what we want. Okay, that completes the armature system, but how do we couple it to the model? Now, this is quite simple. Let's just enable the model so we can see it. First thing we notice is that the model is completely out of place. So the first step is to just hide the armature, so it's easier to see what we're doing, is to move the model and align it with the mock panels. To do that, because the armature motion trackers controls the position and movement of the model, all we have to do is select the motion trackers, and can't do that in pose mode, need to be in object mode, and align the model with the mock. Now I'm just doing it by. That's the first thing we need to do. The next thing we need to do is make the motion trackers children of the mock doors. And we can do this very easily. This is how we couple it. Just grab a panel, and this is the first mock panel. It's this one. Make it a child. Now I could use the Control P option via the key, or I could do it this way, which is much faster, much simpler. Just drop it in. And basically that's how we couple the model to the rigging. It's a very loose coupling. Now if we grab our motion tracker, which is not a motion tracker, our armature, let's enable that. The armature, I'm just going to change this to a stick instead of the octahedral. Let's just select that, pose mode. You should now be able, let's hide the mock. The other thing we never want to render the mock, so we need to click on that. And now rotate it. As we can see, this is not working because I've forgotten something. What I've forgotten is I've forgotten to parent the mock doors to the armature. So let's just go through that quickly. Grab this cube and grab its parent and just go Control P, bone relative, and the same with this one, cube and bone, Control P, bone relative. And now when we rotate this, it should be doing exactly what we want. Let's just hide the mock so we can see that more clearly. So now when I rotate the Z, you can see it opens the door quite easily. Now the other important thing that I wanted to show very quickly is, let's say we want this polycarbonate glazing that's sitting on this side to be sitting on the other side. We can do this very easily by simply going into our model, but we need to be in object mode, and what we can do is we can just add a transform geometry. Because the whole door is symmetric, we can just, in the X location, we can just flip it around by doing the wrong one. Rotation. What you notice now is that it has now moved out. Fixing this again is as simple as just grabbing our motion trackers and realigning it. I don't have to reparent or anything like that. Simply realign it. Now let's just hide our mock. Now we select our armature, our rigging, and we rotate this. We see that it works exactly as we want. So this is where the flexibility comes in. We didn't have to change the pivot point. Obviously the pivot point would have changed now that we flipped it around, and we didn't have to do that because we've separated that concern and we've loosely coupled between the two parts. Alright, the next thing I'm going to show you is how to extend this to make this a 4-door panel. I'm just going to organize this a little bit better. What we'll do is we'll create a sub collection called rig. We'll just add our armature to the rig as well as the extension point, so to have a more clean separation between the two. So we've got our rig. Now for a 4-panel folding door, we just have to duplicate our folding door. So I'm just going to create a new collection and call it a 4-panel folding door, and I'll just duplicate the collection and we'll just move this into this one. Now as we're going to have 4 panels, we just have to duplicate this again and we have 4 panels. But before you do anything, we need to go into the 3D model. Let's just hide this one. The 3D model now is, its data is the one we copied from. If we make any changes to this, it'll change the one we copied from. So what we have to do is make sure that this geometry node, you see it's being used in 3 places. We need to duplicate it by just pressing that, or we can come here and duplicate it over here. So it's got its own data. Now we can go and correct the parameters. It's pointing at motion trackers 2, which is the one we copied from. It should be motion trackers 3. So we need to change that to select 3. And this is not pointing at the right motion trackers. So we need to fix that and fix this one, this one. Okay, so now we've hidden that one. So now we've got these two sitting on top of each other. So what we have to do is we need to grab this one's the armature, because the armature is the owner, the parent of just about everything, and we need to move it next to this pair. So we can just X 1000. Okay, the reason why the model hasn't come through is because we need to go and fix up this one as well. It's still pointing at the it's the one we copied from, that's why it's 2 now. So we need to make it unique, and now it's unique, and this one should be motion trackers 4, and this should be 3, and this one should be panel B3. Okay, now we see our model is correct. We can hide the mocks now, don't need to be seeing those. Okay, now we select the armatures. It's easier to just select them over here. Go into pose mode, we'll rotate this. We'll see that it's not pulling in the second pair because it hasn't been coupled yet. We need to couple this armature to our extension point. Now there's 2 ways we can do that. We can simply take this armature and we can make it a child of the first pair's extension point. So we can just go shift, grab it and shift and make it a child. However, doing it that way, there is an issue. When you parent something, it inherits the rotation, the location, as well as the scaling, and you can't specify that you only want rotation, for example, which is our case, in this case. So when I rotate this, you see it pulls it, but it is also getting the rotation information. So we can't really do that. So what we can do is, let's just disconnect this. Let's just clear the parent. Control P, and do it in other words. Object mode. Control P. No, it's not what we want. Alt P. Option P. Clear parent and keep transform. So we have undone that. The other way we can parent it is to use a constraint. So all we have to do is select this armature, it doesn't need to be a bone constraint, and we just add a child of constraint to the first pair's extension point, which in this case would be this one, and we don't want the rotation information, so we need to disable that. So now that we've parented it using the constraint, back into pose mode, if we take this now, we'll see it's pulling it in. It's what we want. So now we can animate our door. We can take this one, for example. We can rotate this one on its own, and so on. So I'm just going to clear all the rotations. Okay, that shows how you extend it with multiple panels. And a huge thank you for watching. If you found this video helpful, please give it a like and subscribe. Your support will help me immensely, allowing me to step away from the workforce and dedicate my time to passion DIY projects like the enclosed pergola, where the need for folding doors inspired this video, my first YouTube video. You'll find more information and exciting upcoming DIY projects on the channel, so please check it out. And your comments will help me in learning and, more importantly, improving and prioritizing content that matters most to you. Many thanks, Harry from Dad's Project.